Hey everyone, welcome to AI Dojo. And today we're diving deep into one of the most misunderstood concepts in AI and large language models, LLM memory. Specifically, we're talking about short-term memory versus long-term memory, and why most people get it wrong when they think models like ChatGPT actually remember them. If you've ever wondered how chatbots seem to keep track of conversations, this video is for you. I'll walk you through this step by step. We'll start with the fundamentals of why large language models are stateless, then explore short-term memory through prompt context, transition into long-term memory with external storage solutions like MongoDB. This is going to be a thorough explanation. Let's jump in. First things first, LLMs are fundamentally stateless. That's the core idea, and it's where a lot of confusion starts. So, what does stateless mean? In simple terms, it means that the model itself doesn't hold on to any information from one interaction to the next. Each time you send a query to an LLM, like GPT, it's like starting fresh. The model processes your input, generates a response, and then, poof, everything is forgotten. There's no internal memory bank inside the model that's saving your conversation history or learning from it in real time. Let me break this down further. Imagine you ask an LLM, "What is the weather today?" The model responds, "It's sunny and 75 degrees Fahrenheit." That makes sense. Clear skies, warm temperature. Now, in a new, separate request, you ask, "Should I take an umbrella?" If the LLM were stateful, like a human friend, it would remember the previous weather info and say something like, "No need. It's sunny and 75 degrees Fahrenheit today." But because LLMs are stateless, a raw, independent request would cause it to respond with something totally generic or confused, like, "I'm kind of lost. Could you provide more details? Like where you are or what the forecast says?" Exactly. The model has no clue about the previous sunny and 75 degrees Fahrenheit, because that info wasn't included in the current prompt. Each request is completely independent, no hidden memory carrying over. Here's a great analogy to drive this home. Think of an LLM like a brilliant professor who suffers from amnesia after every lecture. You ask a question, they give an amazing answer based on all their knowledge, but then their memory gets wiped clean. If you want to ask a follow-up, you have to remind them of the entire previous conversation. Otherwise, they have no clue what you were talking about. That's exactly how LLMs operate. If you don't resend the information in the next prompt, the model acts like it never existed. In practice, this statelessness is why chat interfaces, like the one in ChatGPT, resend the entire conversation history with every new message. It's not that the model has memory. It's just that the front-end UI or back-end API is bundling up all the previous text and shoving it back into the prompt. Chat history isn't memory. It's just text being resent over and over. When building chatbots, you're not relying on the model's brain to remember. You're engineering the system to feed it the context every single time. To visualize this exactly, let's look at this flowchart of the LLM's stateless processing cycle. Here's how it works, step by step. Step 1. User sends a new message. That's your input, like, "Should I take an umbrella?" Step 2. The system appends the full chat history to the prompt. It grabs everything from before, your previous questions, the model's responses, and bundles it all together with the new message. Step 3. The full prompt is sent to the LLM. Now the model sees the entire context in one go. History plus new query. Step 4. LLM processes the prompt and generates a response. It can now answer coherently, like, "No, it's sunny and 75 degrees Fahrenheit, no umbrella needed." At the end, chat history is updated. The new user message and the fresh response are added to the history store. This cycle happens every single time you send a message in ChatGPT or any chatbot. It's why conversations feel continuous, but it's all smoke and mirrors engineered around a truly stateless model. If this loop breaks, if history isn't resent, the LLM goes right back to being confused, like in our weather example. Now let's pause for a second. If LLMs are stateless, how do they seem so conversational? That's where short-term memory comes in. We'll cover that next, but first, make sure you hit that like button if this is already clicking for you. All right, moving on to short-term memory, or STM. In the world of LLMs, STM isn't some magical internal feature. It's simply the text inside the current prompt. We call it in-context state management because you're managing the state right there in the context window of the prompt. This is how engineers simulate memory for short sessions, like a single chat. Let's define it clearly. The prompt you send to an LLM typically includes a system prompt, new user prompt, chat history, which is previous user messages and responses. All of this is concatenated into one big string of text. To the LLM, there's no distinction between previous message and new instruction. It's all just tokens being processed simultaneously during inference. Short-term memory is ephemeral. Lost after the session ends. Close the chat window, poof, gone, unless you save the history externally. It's dynamic, constructed on every request. Your code or API has to rebuild it each time. It's limited by context window size. Models like GPT-4 have windows up to 128,000 tokens. But that's finite. Stuff too much in, and you hit token limits, leading to truncation or errors. It's not persistent, learned, or stored inside the model. It's not a database. It's just text. What if you want memory that lasts across days, sessions, or even users? What if your chatbot needs to remember user preferences from last week? That's the problem STM can't solve alone. That's where we need something more robust, long-term memory. So now, let's shift gears to long-term memory, or LTM. Unlike STM, which is all about the immediate, in-the-moment context within a single prompt or session, LTM is designed for persistence. It's the mechanism that allows your AI system to remember things over extended periods, across multiple chats, days, weeks, or even different users. And crucially, LTM isn't baked into the LLM itself. It's entirely external, handled through storage solutions like databases. At its core, LTM involves saving conversation data, such as full chat threads, user sessions, preferences, summaries, or key decisions, in a persistent database outside the model. This way, when a user returns later, the system can query that stored data and feed relevant parts back into the prompt as needed. Let me explain why this matters. In STM, everything vanishes when the session ends because it's just temporary text in the prompt. But with LTM, you're building a durable archive. For example, imagine a customer support chatbot. Without LTM, every time a user logs back in, it's like starting from scratch. They'd have to re-explain their issue. With LTM, the system pulls their past threads from the database, summarizes the key points, and injects that into the new prompt, making the interaction seamless and personalized. STM is like scribbling notes on a whiteboard during a meeting, useful right now but erased when everyone leaves. LTM is like filing those notes in a cabinet or digital folder. You can retrieve and reference them anytime later. It's not the LLM doing the remembering. It's your engineered storage system doing the heavy lifting. Common database choices to store long-term memory are NoSQL databases like MongoDB, which are flexible for handling unstructured or semi-structured data like message arrays, or SQL databases like PostgreSQL for more relational setups where you might link users to multiple threads. Wait, why don't we use vector databases as the primary storage for long-term memory? The short answer is, because the job of long-term memory is exact, reliable, and direct retrieval of complete conversation history, not search. When a user comes back after a day, a week, or even months, the system needs to pull their specific chat thread, in full, in the correct chronological order, and tied to their exact user ID or session. We don't want similar conversations. We don't want related discussions. We don't want top 5 matching threads. We want this one exact conversation. Nothing more, nothing less. That's why vector databases aren't the right choice for long-term memory. And with that, we've covered everything. If this finally made LLM memory click for you, hit that like button and subscribe for more clear AI breakdowns. Thanks for watching. See you in the next one.